is a day to talk about biochar. So we're going to be talking about biochar and farming, and we've got a couple of presenters here: Michael Lobato of Lobato Farms and Glenn Wollam of GBT Farms. They come at the biochar with a couple different perspectives. They've used in some different ways. We'll also have Greg Peterson, the executive director of Colorado Ag Water Alliance, talking about a project that gave these two different biochar projects a bit of a boost. So, uh, biochar is kind of an amazing thing. It's a stable carbon source. It can enhance soil cation exchange capacity. It seems to improve soil and water and nutrient storage. And it is really useful at pulling contaminants out of soil and water. So, we're going to be hearing about how biochar is being employed at these two different locations. One's in the Grand Valley, one is up by Berthoud. Two different, very different ways, really. Um, and so before we get going, I'm just going to let Greg Peterson of the Colorado Ag Water Alliance give us kind of a quick rundown on the Ag Drought Resilience Project, which provided some funding for both of these efforts.
Great. All right. Well, thank you, Phil. Yeah, I'm Greg Peterson. I'm with the Colorado Ag Water Alliance. And the past 3 years, we've been funding projects around the state, farmers and ranchers, just to really, the question was, what's going to help you with drought and be profitable? And we've close to about 100 projects now. And we're starting to wind that down and instead really focus on what are the successes we've had and focusing on those projects and scaling them up. And if I'm in the chat, I'm going to put a link to our website where you can learn about all of these projects. And we had a number of biochar projects that came to us. And just a little bit I'm going to touch on this is it's it, biochar is something that's come up time and time again in the past. Often you'll find people who are going to tell you that it will solve all your yield, water problems, soil problems, and maybe even cure cancer if you rub it on you in the right way. And it's been we had we had some really interesting projects that showed us how not to use it and then how to use it. Like for example, we had one project that demonstrated, yeah, they applied biochar to a fields and had an improvement on soil moisture capacity.
Mondays.
Oh, and it cost, oh, sorry about that, but it cost $4,000 an acre. I don't really care what kind of impact it has when it's costing $4,000 an acre. That's not possible for most people. And so, but these two projects we're going to talk about today, they really demonstrated how to use, when it comes to biochar, less is more, and how to do this in a way that's economical, which is important. But then also the mechanical side of this. We didn't know it when we started this project, but with Michael and Glenn, they're not also just farmers. They're actually tinkerers. And boy, especially I've been to Glenn's farm. There's more equipment. There's just equipment all over the place. And how to actually apply biochar in a way that's feasible and works well is a problem we didn't think about, but that both Michael and Glenn it was right in their wheelhouse. And they were really able to do that well. And I'm glad that we lucked out with having them do these projects. And so I'm going to stop there and we'll just move along.
Okay, thanks, Greg. So, Michael, if you want to go ahead and start sharing your screen, and while you do that, just a couple of shopkeeping notes. We will be recording today's webinar, so you will be able to access to the recording. And then if you have any questions, feel free to put those in the chat anytime during these presentations, and we will have some Q&A at the end. So, okay, Michael, we can see your screen. Michael Lobato is our first presenter. He's a small acreage farmer and research associate at the CSU Fruita research station over in the Grand Valley. And so he is going to be covering what they are learning from a multi-year biochar trial on irrigated forage over there. And I think at the end, he's also going to show us some new biochar injection equipment that he just created and is kind of starting to deploy out in the field. So, Michael, biochar has been used to enhance soil fertility for thousands of years, but I think we're just now getting acquainted with it here in Colorado. Talk about the impetus for why you wanted to do this multi-year project over there and how it's working.
Thanks, Phil. Yeah, I just got started down the rabbit hole of biochar in maybe 2022, 2021. Uh, Partner on this project, Jerry Nelson, he's on the call, and Holly Stanley. They've helped me throughout this project. But um, Jerry brought this idea forth as a part of his work in a nonprofit, and I just had some questions if we could I was kind of enamored with the material, and I wanted to know if it could quickly increase soil moisture, and if so, how much. And then my next question was, well, how do I put it in my 3 acre native grass pasture that I just planted? Broadcasting or tilling wasn't really an option. So, which led me down this path to find a more optimal, feasible way. So, yep. Um, so that's why we call it vertical point injection, improving drought resilience with a novel soil architecture modification method using biochar. Um, it's myself, Jerry, and Holly. And Holly was a student at Colorado Mesa University at the time, and she's been with us on the project since. Um, Jerry is a professor emeritus of University of Illinois, Urbana-Champaign. And after I had this idea in 2022, I went and sought some grants, came across CAWA's Lore Foundation, and then Citizens for Clean Air, which is the nonprofit that Jerry's a part of. What material we used is pistachio shelled biochar from V-Grid Energy Systems in California. I chose that because of its high carbon content and density to put through this machine. And like I said, this is all just a proof of concept. So I needed some high quality material. We applied it at 1.56 tons an acre, which is very low compared to what's in literature. And we applied at 6 to 8 inch depth. And this is located at CSU Grand Valley Research Station in Fruita. And the crop is dryland grass, but it's furrow irrigated. And that's just the grass that was there, established in 2017. We started fall of 22 was the concept, and we applied it in May of 23. So the question is, without mass tillage or disturbance, can you quickly modify soil to hold more water and improve the biology, making it further drought resilient? Why biochar in Western US soils? Well, overall, they're low in organic matter and water limited. And what is biochar? Extremely porous carbon. So a gram is, 300 meters squared of surface area, and that translates to 25 football fields per pound. So it's hard to fathom that, but uh, that's what it is. So what can the biochar do? It can absorb into the pores and adsorb onto the surfaces, both water and nutrients and microbes. And so the soil we're working with is intsols, and intsols they comprise about 15% of Western US soils. Sorry, guys. Okay. So the question was, the beginning of this journey, how do I apply biochar? Well, the most common is broadcast followed by no tillage. That's subject to wind blowing it away. Minimal tillage, you can, maybe disc it in the first few inches. And then heavy tillage, you could plow into deeper root zone depths. But in my case, that wasn't an option because I had just planted my crop. So I was looking at other ways to do this. So my solution must apply a minimal amount of material to reduce the cost while optimizing effects, and apply the material to the root zone depths and minimize the disturbance to the crop and soil. So the first idea was to aerate, core aerate, and then fill the holes, but that was pretty complex. And I dubbed this process vertical point injection because I couldn't find a term that kind of described this. And what this creates is hot spots. They're localized areas of unusually high biological or nutrient activity. And they end up acting as a soil battery or reserve for these resources in times of drought and microbes. These may be the last places that microbes or water will remain in extreme drought situations. And why this works is soil by itself is the pore spaces are intergranular, meaning everything moves in between those grains. While biochar is very porous, it's intragranular, so it can hold materials within itself. So organic matter does this too, but decomposes over time. These structures or granules would remain virtually indefinitely. So what else you see with this? These vertical columns act as a conduit from atmosphere to surface to root zone. Here we are using the golf turf injection machine that I had found, searching for a solution to test this proof of concept. It wasn't ideal by any means, but the machine that I envisioned and how to deposit it literally I couldn't locate such a machine. And so this was the closest we could find. And so that's what we used. I had to rent a huge water pump there to supply the water. And you can see in the middle photo, a deposit about 6 inches deep of biochar there. Okay, this is a 2x2 strip trial. We have 4 total strips. Strips 1 and 2 get irrigated once a month. Strips 3 and 4 on the east half, they get irrigated twice a month. And in each strip, we have 3 sensor stations, and each sensor station has 3 soil sensors at 6, 12, and 18 inches deep. Thanks to Perry Cabot, who I work for, he's let us use all of his excess equipment that we repaired and updated. And that's why we were able to build this dense sensor network. You can see some of the remnants in the middle photo in the auger hole there of some biochar, and then just how the sensors are positioned at each station. So let's see. Oh, there's Jerry downloading some data right there. That was near the beginning of the trial as well. So does biochar increase soil moisture? That's the big question of this study. Over 4 years now, collecting data every 15 minutes. Yes, it does. We just shift the moisture signature up, and on average at the 6-inch depth, you see the different watering regimes. So for example, let me show you. So right here, 38.5% more in strip 1 than strip 2 at 6 inches deep on average over the 4 years. 17.5% more in strip 3 over strip 4, and that it gets irrigated twice a month. So we see more benefit and more larger drought effects the less water it gets. Of course, the more water you apply, you still see benefits, but they're just not as apparent. And then if we look at the 10th percentile minima, which is the 10th driest VWC, volumetric water contents of the sensors each month, you can see that these lows of the biochar blue strip just do not hit the lows that the non-treated does. Of course, this is still dry. I'm not arguing that, but I would much rather have an expensive crop here than here. And if you do the math over that difference right there, that's 41% difference in moisture. And you know that these differences right here could mean, you know, the death of a crop or survival of an expensive high value crop in an extreme drought event. Infiltration, we see in the sensors, the blue lines here, these strips filled to capacity. This is strip 3, filled to capacity about, I can't show you here, but it's about an hour and a half quicker than strip 4 did. Strip 4 filled to capacity over here. And so that reinforces the vertical conduit concept with the ability for nutrients and water to flow downward rather than off. And as far as bulk density, when you add a porous material to soil, you expect the bulk density to decrease, and that's what it did. We don't have a ton of samples, but from what we've taken, it's about 9% less bulk density in the treated strip 1 and about 2 to 3% less in strip 3. Okay, the hay and forage yield. This is a dryland grass crop, so it doesn't yield a ton, but we still looked at that. You can see they both increase over time, which is good because when we took over the field, it was kind of on the back burner, so it wasn't actively being watered or cut or anything or fertilized. And so that's why the yields have consistently increased, because we're tending to that field now. Overall, the biochar strip irrigated once a month lost 7.8% yield, and the biochar strip irrigated twice a month lost 9% less than the control. Over here you can see this was taken in June of 23. Over here you can see a dark strip number 1, lighter strip number 2, and a dark strip number 3, and then strip 4. So that spring, strips 1 and 3 were very they were much dark greener, and that was probably best explained by the NDVI and SPAD testing that we did with the leaves, and they were higher, so that does make sense. And that only did that spring. It doesn't really continue to this day. Although we got less yield in the biochar strips. The RFQ, the hay quality basically increased. You can see these blue lines trending farther upward. The control is relatively flat. Hay quality over 4 years is trending downward in the irrigated twice a month. And while that the biochar strip irrigated twice a month is also increasing. So yeah, the fiber quality and digestibility did increase in the biochar strips. And it doesn't necessarily mean the biochar did that, but this could also mean these species are responding to their respective environments. So maybe some species have emerged where there's a little more water. And we see emergence of bird's foot trefoil and alfalfa in the biochar strips. There's a little bit in the others, but not near as much as the treated strips. And we didn't plant that, and there's no history of bird's foot trefoil there. So I think that's just more evidence of species kind of expressing themselves as these soil conditions change. Fertilizer recommendations. Overall, we've had to apply 31% less nitrogen to the biochar strips based on soil samples. Year two, which was 2024, literally recommended no nitrogen. I think it might have been 5 pounds an acre rate, but not on the order of near hundreds of pounds per acre that the controls needed. So because of that 2024 year where we didn't have to apply much fertilizer, our nitrogen use efficiency is dramatically better. So that's a good thing. Interestingly, the manganese, which isn't super critical here, but it did the recommendations did increase in the biochar strip, so it was probably absorbing it from the soil. We looked at soil health metrics using standardized values as well as two-way ANOVAs. The standardization is because our first soil test is prior to any amendment, so these parameters could start off differently. So we have to basically make it a fair comparison. And so after all the analysis, salts and sodium only decreased in biochar 100, which is irrigated twice a month, suggesting a strong interaction effect of biochar plus increased irrigation. You can see over here, nutrient retention and storage was most driven by biochar here, potassium and nitrogen, which makes sense. That's what we've seen in the fertilizer recommendations. And you can see a big interaction driver between water and biochar for these ionic salinity metrics. And then the soluble nutrient dynamics, largely dictated by some irrigation and a few interactions. Soil health scores trend downward over the 4 years, which is interesting. It doesn't matter if treated or not. My best guess is, we're increasing production, so it's inverse to the hay almost exactly. So as our production has gone up, our soil health scores have decreased because of, I guess, nutrients being used up. I don't really know why that is, but it's kind of an interesting thing. Or it could just be finding its equilibrium after we started this trial. Looking at soil biology, PLFA, which is phospholipid fatty acids, that's basically looking at the stressors of soil. So are these microbes under stress during drought? And These primary drivers right here suggest that the biochar has buffered those stress effects in in the treated strips. These markers are lower as well, and the fungi to bacteria ratio is increased in BC 100, which is increased water and the biochar. So overall, we have a higher microbial biomass in the treated strips, the blue versus the red. So those metrics are pretty clear on increasing microbial biomass. So the economics, this test right here was $6,000 an acre. We did about less than 1 acre. Obviously, that's not practical. Most of that cost is reflected in the golf turf application. But the machine I've been working on would make this possible for approximately 500 an acre. And this isn't limited to biochar. Other materials or minerals or combinations could be used. Even you must consider the savings of water, fertilizer, tractor passes, labor, incentives, and carbon credits to make a informed decision. And like I said, if your crop survives the extreme drought and a high value crop, that's a hedge or an insurance against crop failure. So what would this be for? Mainly your perennial, minimum or no-till systems, rangeland, pastures, vineyards, orchards, reclamation, soil remediation, forestry replantings, or urban green belts. It's not really for your annual crops. This method isn't. It kind of defeats the purpose if you turn that soil over every spring. One and done, we expect this to be one application needed, so it's kind of a one-time investment. We don't really know if more is better, less is better. But most of the literature that exists on biochar are upwards of 5, 10 to 20 tons an acre. We applied at 1.5 and seen these results, suggesting it's not how much you apply, but how it is installed in the soil. So to summarize, 38% more water at 6 inches deep, modified quickly. 10th percentile minimums increased 40% over controls, buffering against drought. We lost 8 to 9% yield in dryland grass hay, but quality improved, increased soil metrics, and a decrease in microbial stress. Decrease in nitrogen and fertilizer inputs, thereby increasing our nitrogen use efficiency by about 29%. This is the machine I've been working on, a prototype for about a year, hundreds of hours. It also applies liquid inoculants or nutrients right behind the injection point. This is patent pending, and at this link here that Kawa can provide, you can see this in operation and see how it works. Please visit biocharresearch.org. That's a site Jerry built. You can read all of our soil tests, every test we've ever done. You can see interactive soil sensor data. So you can explore every bit of data we have right here. And then I'll provide this document so you guys can explore these links if you wish. But that's all I have. Thank you.
All right, great. Thanks, Michael. Lots of questions there, and I think it's working to put those in the chat. We seem to be getting those answered. So we'll go ahead and keep rolling. And again, we'll hit the Q&A at the end, but we want to hear from Glenn first. Sarah, can we go ahead and Michael, if you'll stop sharing. Yeah, Sarah, if you can show Glenn's slides. And so Glenn Wollam is over here on the Front Range. He is a farmer, lives in the Berthoud area, and considers himself a newbie on the block. He's only been farming for, I think he said, around 25 years. So I think he said that he ended up with the land that all the other old timers didn't want. So that's been kind of his plight. And I think that's part of the impetus as to why he's been really innovating what he's done. And Glenn has developed a compost blend that includes biochar and some other interesting stuff that he has been using on his fields for a few years now. And so, Glenn, are you ready to share with us kind of what you have found and how your process works?
Certainly. Good afternoon. I'm certainly not the scientist that you guys are. I'm, I'm a farmer, I'm a mechanic. I was fortunate enough to be able to go to Cornell University, but it wasn't because I was brilliant. It's because my uncle was on the board of directors. I did from it get an arboriculture certificate, which worked out pretty well. Um, I grew up in a lot of farmland on the East Coast, which was entirely different than what we have here in the Midwest. I grew up around a lot of potato farms, cabbage farms, et cetera. It was all truck farming that was in there, and was always kind of enamored with it, but never really got a chance to do that. I spent most of my time in the trees as an arborist. But when I moved to Colorado, the opportunity came for me to purchase a piece of property that had been a farm. And of course, that leads to horses, which leads to growing hay, which leads to I can't afford to buy hay anymore. So I had to make my own, and hence this whole thing kind of came around. Um, I started playing with row crop back in 2000, basically. Um, every piece of equipment I have, I've built from dust, I guess you could say. So everything for me is really based around working with what I have available to me. And now, fortunately, I have some pretty cool things available to me because of Greg Peterson and fine people who got me into this program and gave me the opportunity to get some better equipment to work with. Uh, Pretty much my soils out here are clay. There's clay and there's clay. And then there's some more clay with a little bit of sand in it here and there. So trying to get the soil that I have to accept anything in any way, shape, or form is really kind of tough. I don't like spending a lot of money on fuel, so I do as little tillage as possible. Although with the soils that I have, I'm really forced to do. I'm going to call it minimal tillage, which is going to be 8 inches, is what I'm really going to call minimal till. Um, and I'm not a big believer in spending a lot of money on chemicals, i.e. nitrogen, not necessarily a chemical, but I'm just not real big on spending that kind of money because I have very, very little irrigated land. It's all dry land. So to me, it's just pretty much a waste of time. If I do put on a fertilizer on hay fields, et cetera, everything's encapsulated because we just never know if it's going to rain over here. With our particular situation right now, we're on a fourth year of drought and a severe drought. So it's been kind of difficult. Fortunately, I was introduced to this in right around 2000 when some of the folks up at CSU were doing some studies of Little Thompson watershed. And fortunately, Little Thompson kind of winds through several of my locations that I operate my farms on. I can't get any water out of it, but they hiked around, et cetera, and were able to access the river. And they introduced me to the whole concept of, well, why don't we come down and do some soil tests for you? And one thing led to another, and I got to meet some really, really fine young scientists, which completely blew my mind because I'm 70 something years old and I haven't met young people as brilliant as these guys were. And they're just genuinely incredible. They wanted to help people and they did a huge task for me, just not only in explaining soil analysis to me, et cetera, because like I said, I'm not a scientist, but into getting me introduced to people like Greg Peterson. So that's been my task is working with what I can. Your previous presentation has some, phenomenal costs involved in applying the biochar. I'm working with the biochar within a compost product that I can get, and all of the products I can get for absolutely for free, with the exception I have to haul this stuff in. Fortunately, part of our outfit involves a fair amount of trucking, so I do have my own trucks, trailers, etc. Um, but we bring this material in as needed, set it up in windrows. We'll stockpile it on a farm. I'll build my own compost. I'm able to have access to a lot of the local landscape fellows, I call them, have tons and tons of grass clippings that they bring down, and they are very happy to get rid of them at my place, and they'll deposit them along with my piles of compost, and that all gets blended in. That to me is sufficient nitrogen for me to work with, right? Just in that itself, just the grass cuttings work very, very well. We get some leaf debris in the fall, which works out as well. Um, and we just take these piles and start to spread them out. And we'll take a loader and move them into long, drawn out piles that are approximately 10 feet high. And we try and keep them within the farm, so that we're not having to transport this stuff all up and down the road. The whole concept here for me is I'm trying to create a fertile base for the lousy soils that I have by using a compost treatment to effectively change the cation transaction that's going on. I'm not a scientist, but I do understand that the soils have to work together. And I've got, 3 different kinds of soil to work with: clay, and some sand, along with this material that we're working with at this point. The interaction of the composting that we're doing and the soils have just improved the health of the soil itself. And effectively, for me, if I walk into a field and I can, even if it's just been, let's say I've just harvested it, I've just taken grains off of the field, I've already run a combine across it, I've already run some grain carts across it. But if I can still take my hand and stab the thing into the ground, and yeah, I did karate for a couple of years, but I don't have that anymore at my age. But I can still stab my hand into the ground and grab a handful of soil, even after it has been compacted. And the soils that I'm working with now, I used to stand in those fields 4 years ago, and I would walk out there in the middle of December, and wondering what in the world I'm doing, and the soil would be blowing around me. And my soil's not blowing as much anymore. Um, yeah, it seems to be relatively stable as far as a soil that I can pick up and grab. I can grab a wad of soil, even in this current drought system right now. If I can get some soil that's out from 4 inches down from the surface, I can grab it and I can make a ball out of it. Um, I can make a ball, but it's not the clay ball that would become plasticized when you pulled it together. I can make a ball and I can snap it and it will fall out of my hand and break apart. Um, as far as, my tillage results, when I'm working soil, pre-plant, even in this drought, if I'm disking at 8 inches, I don't come up with the big donuts that I used to come up with before, that I would have to go through with a plane and either bury them or break them up, with multiple passes with a mulcher. At this point now, I can run what I have a Wilrich machine that we refer to as a seed bed producer. And I can run that through and literally make a seed bed out of that. It does have rollers on the back of it, so it doesn't require me to mulch, but I can just make a single pass, and if I have any clumps, it'll break apart. So we started this initially, I think my first application was in 2023. And it was effectively experimental. I had very little equipment to work with. I was able to purchase this Wildcat composter, it's a dinosaur, but it's a fabulous machine. It's not self-propelled, so I've got to work it on a tractor. But you make 3 or 4 passes out of this thing, and it will take what you have windrowed with a loader in a relatively sloppy manner, and actually create these, wonderful, just, perfect furrows of material. Very simple to calculate in volume, very easy to work with. It's extremely, plastic. It'll hold its shape very, very nicely. As you can see, we take one pass down each side. We actually take multiple passes. The pile that's on the right-hand side of the screen has only been, piled up with a loader. It has not yet been windrowed at all. This particular pile that you see right now has probably been run across the composting machine twice, perhaps three times, and it leaves this lovely little canyon in the center of it, which we use to apply our beer waste. The beer waste I'm able to get from our local Berthoud Brewing Company. They've got several locations, and they're happy to not have to send it down the sewer because the town really gets upset with that. And they save it for me in totes. We go pick them up, drop them in a big tank sometimes. Sometimes we'll take it right out of the tote and apply it directly. The beer waste I find just it activates every microbe that's in that soil, and it will heat it up tremendously, and it appears to be cooking any weed seeds out of it very nicely. With my location, I have a horrible time with kochia, so no matter what I do, I'm going to have kochia. But this seems to be pretty good. My fields do not require as much maintenance that have already been composted. The ones that have been composted several times require very little maintenance. In fact, all I really need to do is run through it with a sweep cultivator, typically twice over the summer, just to keep the weeds at bay. I do. I'm not a fully organic farmer. I have organic farmed in the past, and I still do some, but I try and limit my weed applications to one time a year, and that's typically pre-plant. Here is another shot. Again, you're looking at windrows that are being turned for the first time. The machine crawls along. It moves along at about 1.5 miles an hour. It's got a granny gear on it. It does need to have that because the torque of it tends to want to pull the tractor back up into the pile. So you spend a lot of time leaning on the left side of that steering wheel as you're going down through here. It's very, very effective in mixing, and it is. By the time we get to our last mix, that machine is actually, the outboard wings of that machine are dragging on the ground. So you're actually picking up just a little bridge of the soil that the compost mounds have been placed on. It's not a bad, we can go through, that's a 300-yard pile that's on there. We try and do the piles in 100-yard strips, depending on where we are. And I use 100 yards just because I can break it down into, I can break it down into 100-yard pieces. I've got 300 feet here, 300 feet there, 300 feet here. It's easy for me to apply the biochar to these piles and apply the liquid materials to it. Like I said, I'm very, very scientific. So my very, very scientific 4-yard loader, I can fill with biochar and apply directly into the top, into that ridge of the entire course of the windrow. One of these days, I'll invest in what they call a side slinger, and be a lot more efficient. Instead of applying the biochar in a 6.5-foot section, I'll be able to drop down the line and do this. And once the material is completed and set in place, I just use my H&S, and it spreads very, very nicely, very evenly. My application rate of the complete compost material is basically at 5 cubic yards an acre. Of that, 30% of the weight of the mass of that is going to be in biochar. So you're only looking at 250, 260 pounds per acre of the biochar itself. The biochar that I'm picking up, it comes directly across the street from one of my farms over on Route 7 here in Berthoud, which is biochar. They call it Biochar Now. And my understanding is most of their material actually came from the Centennial fires from a couple of years ago. I don't know. I haven't picked any pieces out that look unfavorable, but I get my stuff in a 3/4 inch size. And by the time it's been milled through my Wildcat machine, it has been reduced to size to approximately 3/8 to 1/4 because it's been ground several times. I can walk through the field at this time, after I've done a pre-plant prep on it, and you can identify pieces of biochar that will work its way up to the surface. You'll walk around and you'll see black spots all over the place. What has it done for me? I know it's held moisture for me. Um, Again, this particular field that you're looking at right here is a dry land field. It has two pivots on it that have not worked in years because there's no way to get water to them. The pivots are operable, and one day maybe I'll get some water, but this particular field has not seen water in years. Um, After my first application on this particular field in 2003, we split the field in half for our study per se. And I put sorghum on that's the following spring. I had had sorghum on this field prior to that, several years earlier. Um, and my yield results on this brought me on the area that we had done compost and biochar. I had a 0.4 ton increase in yield. The balance, other half of the field, the other 25 acres maintained the same results that I had prior to that. They were something to the tune of two to 2.25 tons an acre of sorghum, and we're talking green chop. One thing that I did notice though in the biochar affected area was the lignin strength of the sorghum. My my harvester, my swather, was working about 10% overtime on that. The rate on the harvest, as far as the engine working rate, was about 10% higher on the area that had been biocharred. This is a wheat field that we worked with. This gave me an increase of 20% on this particular field on my wheat. This is dryland wheat. We got really close to 70 bushel on this, compared to our earlier 45 to 50 would have been a good day in dryland on this. Um, Again, I'm not a scientist. I can't give you the rates. I can tell you how we do it. I can tell you how much we apply. I can raise my right hand and tell you that everything is applied in an even fashion. I'm able to apply things with a GPS, so I'm not overspreading. My H&S spreader that I've got there is incredible. It's wonderfully accurate. It does a very, very smooth job of spreading everything out very evenly. Um, and my application it's about even in factoring the cost of fuel, et cetera, is somewhere around the cost of about $75 an acre. So I'm negating using any nitrogen because I'm using a compost. I'm increasing my soil capacity, uh, the whole arrangement of my soil has changed. It has, actually become something that looks good. It's not just plain gray, or tan perhaps at times. It actually has some character to it now. It's starting to look like some of the fields from some of the older farmers that have been here through grandma, grandpa, and their grandparents. And we're actually starting to see some yield and some capacity out of it. And it's not just that, it's the consistency. I don't have blank spots anymore. Typically this field would have had some blank spots in the middle of it, and that's a pretty good run of wheat right there. Um, it's not as tall as I would like, but I'm also not into the straw business that much. Um, Typically most of my straw when I'm running my combine, I'm just spreading it and I'm going to get it back into the ground. You'll see back on that early file photo, where you can see where the biochar had been applied to that center of the windrow. You'll see that there's piles of straw over there that we're preparing to mix in on one slide back, I believe. And that's all manual labor. We just go through and just shake it out off of a loader bucket. I'm sure I'm sure OSHA would just love to see one of my guys standing in a loader bucket, busting off pieces of straw, going into a windrow. But that's our application. That's what we're able to work with. I don't have a straw chucker. Um, but everything that I'm working with here is all free, excepting the biochar. Although Phil just did set me up with some biochar that I got for an extraordinary number. Um, Very, very simple operation. Very, very inexpensive operation. I'm again, I don't have graphs for you. All I have for you is what I can tell you and what I can show you in the soil itself. Uh, the only analyses that I have here are between some laboratory reports that came through CSU, and one from my local agronomist over here. And looking at these and looking at the dates on these guys, this goes back to 2020, and you're looking at Polis, and yes, that is the same Polis that we're all talking about. That particular farm had a cation capacity of 21. And as you move forward on that, you'll see that that increased up to a 25 and a half over the course of 3 years. And that was a single application. So that particular piece of property is the one that was 50 acres that we split into 225s for our initial study with Mr. Peterson. And I was able to see what my actual results were on the first year. That following fall, we went back in after we had harvested, and obviously we harvested our sorghum was done in late July. Um, and we went back in and put biochar and compost on the balance of the field. We basically composted the entire place. Um, but again, you'll see that east and west, those numbers have graduated from 19s to all the way up into the 25s. Can I explain to you exactly what the cation exchange is? No. The young men and women that were at CSU explained to me how it was working, and that it would literally help my soils blend together. And it is exactly what has happened. My soils are actually now beginning to blend. I can't tell you what it's like 18 inches down. Um, my lands are all leased. I only own 5 acres of my own. Everything else is all leased land. Um, so I'm not in it. I'm sure I could go down there and say, hey, you mind if I dig pool and find out what we got going on below it? So all of my interest is really up on the surface to see what's going on. We'll see what happens. I somehow I don't think that God's going to give us a fifth year of drought over here. Um, Otherwise, I think I might just move to the Middle East or something like that, or Kansas maybe. Um, but I'm hoping that we see some results. We get some soil in. Everything that I had this year, as far as grains go, had to zero. We had literally everything died at 3 inches tall. That was it. We didn't get anything at all. I got my first substantial rain on Sunday night here. That's the first thing. I believe we got an inch of rain on Sunday night in one good shot, and it was dry in 15 minutes. Um, that's what I have for a presentation. Let me know what you think.
Glenn, that was great. Question, do you use any livestock?
Do I have any livestock?
Do you, on any of your fields, do you actually graze any of those with
Yes, I
livestock?
do. I keep a couple of cows and a couple of hogs and a couple of turkeys, but I have to keep them off-site on one of my other farms. My wife has a tendency to name everything she meets.
And the other question was, do you know what the carbon percentage is of that biochar now product?
I do not know. I would have that somewhere in some files. I did get a complete analysis on the first time that I bought from those guys. And I apologize. I don't know. I'm really not sure. I did share those results though with the folks at CSU, and it would be buried somewhere in the annals of this lovely office of mine. Um, I will see if I can't pull those out and find them.
Okay. And if you can find them, we'll sure post them along with the recording and the other information. And Michael, can you go ahead and share your screen? Michael has developed a piece of equipment which he showed.
Okay. All right. So yeah, this is what Michael did this winter.
So Michael, if you want to explain to us what's going on there and how this works.
Okay, right there you have some 20-inch coulters pre-slicing the soil in front, and then those behind that is the entirely custom knives I built. They don't exist. You can't find those. You can't buy them. And then all of the mechanism to deliver the material I had to build. And then right there you can see some liquid squirting out into the injection points, kind of inoculating it in the soil. That prevents you having to pre-inoculate it or mix it with compost, because compost is many different sizes and won't run through machines. So a good way to do that is to add the liquid as it goes into the soil. And yeah, that's spaced 30 inches apart, the knives. And this is just a prototype. You could scale this bigger, better, everything. This is just to prove the concept that I could do it, so it can be done.
Right.
How much is that injecting?
Let me see here. It's actually even less than what we applied on the trial field. It's about half, so it's about a half a cube, no, 1 cubic yard an acre. So it's about half of the trial field. And that's due to some limitations of that geometry of the machine. But I mean, you could in theory just make it whatever you want, but that's what this does.
Okay, 1 cubic yard an acre, that'd be around 200 pounds an acre plus or minus, right?
Probably 300 to 400 pounds an acre.
Depending on moisture level.
Yeah, exactly.
Okay. Well, we're running up against the clock, so we're unfortunately going to need to wrap up here. We've got a lot more questions, but I think we'll try to address those offline. And one question was, is the liquid just water in terms of what you're injecting there? I think you said that was water, right?
No, it's like compost teas or extracts.
Okay.
Basically, you're adding your biology there.
So just to kind of wrap us up here, Greg, I think you wanted to just say a kind of a final word as far as where we go from here in terms of Kawa's perspective on the ag drought resilience side of things.
Yeah, so I think from these two projects, we're really learning how do you create a blueprint to do this at scale in a way that's economical and logistically possible. And so from these, we're starting to just identify and just see who else is interested in doing these works, and essentially taking what Glenn and Michael have been doing and try to put that and some of this we're gonna be applying for funds, trying to find funding to scale these up, but just seeing, okay, can we replicate this on other people's farms and operations, and how exactly to do that. And so if you signed up for this webinar, you'll probably be hearing from us and getting an email about interest in participating in a project like that, or please reach out to us if this is something that you're really interested in. But Glenn and Michael, thank you so much for all the work you put into your projects, and I feel like we've got a lot out of this.
Thank you for the opportunities.
Thank you guys. I appreciate it.
Yeah, I really appreciate it. We'll call it good at that. Again, the recording will be available in a couple days, so check back. We'll try to send an email out to everybody that registered when that's available. So thanks for everybody for joining us, and we're going to go ahead and conclude this webinar. Have a great afternoon.
Thanks
Thank
all.
you.